Good morning. I promised you a little look at question 8, the second of the two questions that I'd asked you to do yesterday. It was quite hard, wasn't it, to sort of extract the information. So I hope you were able to see that what we were dealing with here was a binomial probability distribution where n is 36, you take 36 trays, and the probability of success, which is it being able to survive and plant on, well, 12 of 36 did, so that was 1/3. And so that was your null hypothesis, that the probability was 1/3, but the gardener thinks she's going to improve the number that survives. So this is the alternative hypothesis. So that means we're looking at the upper tail. And we were testing at the 10% significance level. So we were looking for the first value along here that gave us a probability of less than 0.1. So 0 to 36, again, not to scale. So the probability of 16 to 36 on your calculator gave you 0.1094, and the probability of 17 to 36 gave you 0.0584. So this is the first value. It's not the closest to 0.1. There was that slightly ambiguous question, which is the only time I've ever seen it. I've certainly never seen it in an exam. Now, the critical value is the first value that gives you a probability of less than that. So that's our critical value, and our critical region therefore is any value greater than or equal to 17. Just one point about that on the calculator. When you've got a probability of 1/3, you need to use your fraction button, but you can't use it as you normally do, so you have to do 1 fraction button 3, and then when you press enter it converts it for you. So it then had this part C, state the probability of incorrectly rejecting H0. So we are saying that we're going to reject the null hypothesis if we get a value of 17 or more. But the fact of the matter is that unlikely things do happen, and it is possible that you can get a value in here and the probability still be 1/3. So the probability of incorrectly rejecting H0 is this probability here, that answer there. And it was very similar to the previous question that we did in the video where it said what's the actual significance level. So there we go. Let's move on today then. Let's play a game of spot the difference. Can you see how this question differs from the ones we've done previously on hypothesis testing? It's here. In this question, we are not testing to see if the probability is greater than 0.4 or less than 0.4. If we were testing if it was greater than, we'd be testing up here. And if we were testing if it was less than, we would be testing down here. That's called one-tailed testing, one-tailed test. And everything we've done so far in hypothesis testing has been a one-tailed test. Now here we just think the probability is wrong. We don't know if it's bigger, we don't know if it's smaller. So in this question, we're not going to do a one-tailed test. We need to check at both ends. We don't know whether it's bigger or smaller, so we need to check at both ends. And at the 5% level of significance, what we do is we split that probability in two. So what we're looking for is not 0.05 here, but 0.025 there and 0.025 there. So we're trying to find the value here, which gives us a probability less than 0.025, and we're trying to find the value here that gives us a probability of less than 0.025. We're dealing with a binomial distribution where we're doing something 20 times. So we know we're going from 0 to 20. So let's see if I can pause at this point and see if you can work out this value here that gives you a probability here that's less than 0.025, and this value here that gives you a probability of less than 0.025. This is the binomial data, isn't it? So probability of 0.4. So that's what we're going to use on our calculator. Have a go. Okay, I'm hoping you got 3 and 13. So when I looked at the lower tail, I found that a probability of between 0 and 3 gave me this. But if I did 0 to 4, I got a bigger value than that. So this is the first value that gives me a probability of less than 0.025. Remember, we've split that significance level into 2 halves. 13 to 20 gave me a probability that was just less. And that as a percentage is 1.6%. And this as a percentage is 2.1%. So the critical region is, well, it's 2, isn't it? It's when x is less than or equal to 3, sorry, important that, isn't it? And when x is greater than or equal to 13. And the actual significance level of the test are these two probabilities added together. So it's actually 3.7%. So the critical region is a misleading phrase, isn't it? Because really we should be saying critical regions, because we've got 2. X is less than or equal to 3, greater than or equal to 13. And here's a second question where we're not asked about critical regions, but we're given a value and we're asked to test to see if that value is fishy. So this is like we were doing last week, but it's with a 2-tailed test. So let's just get our parameters. So we're going to say, right, x is the number of times you get heads when you flip a coin. We're flipping it 20 times, and I know the probability of getting a head is a half. And I know that the peak is going to be at 10, isn't it? 20 times a half. Yeah, that's what I'm expecting. I'm expecting to get 10 heads. Now we're asked to use a 2-tailed test, so we're checking. The null hypothesis is the probability is a half, but we are checking to see if it isn't a half, not greater than or less than. So we're looking above and below, and that means we have to split our probability in 2. Now it's a 5% significance level, so that means again we're looking for 0.025 there and 0.025 there. But this time we're given a value. We're given the value 6. Now I know 6 is lower than the expected value, so I know I'm looking down here, but I still have to split my significance in 2 because I'm told to use a 2-tailed test. I'm not checking if the probability is less than. I just don't know whether the probability is a half, so I've been told to use a 2-tailed test. It's a subtle difference, but it's an important one. So let's get the calculator set up. So I want to enter 20 and 0.5 as my 2 parameters, and I want to know if 0 to 6 gives me a probability of less than that. So 0, 6, it is not less than that. Okay, so the probability that x is less than or equal to 6 is equal to 0.0577, 4 decimal places, and this means that there is not sufficient evidence to reject the null hypothesis. And in the context of this question, that means we haven't got enough evidence to conclude that the coin is biased. We don't have enough evidence to conclude that it's biased. So again, a few questions to try on in exercise 7b, page 104. Have a go at question 6 firstly. This again has this rather ambiguous statement about as close as possible. It is the first value that is less than that probability. And question 9 on the same page, again, the same ambiguity, but it is again, it's the first value that gives you a probability of less than that. So that's question 6 and question 9 on page 104, and then skipping forward to page 108 and 9. So question 3 is worth doing. This is where you're not asked to find the critical region, you're given a value, in this case 9, and you're asked to test if it's in that critical region. And then on the next page, 7, 8, 9 and 10 are all worth doing. I'm going to say do at least 7 and 9, but they're all, good questions to try. And I would be grateful if you could email me your solution to question 7. As always, I know you can look up the answers, but I would just be keen to see just how you're doing it, and it obviously just reassures me that you are joining in with the fun. Hope you're all well, and I will send you a couple more videos next week.